Hello, in continuation with the previous video, we will solve exercise example 14, 15 and 16 in this video. So in 14th example, we'll just look at it, we'll not solve it in detail, okay? So what is given to us is, we are given this three lines, that is y is equals to m1x plus c1, y is equals to m2x plus c2 and x is equals to 0. So these are the three lines that are given to us, and if you plot it in on the graph you will get this sort of a triangle. So what we are trying to say, the concept is that if you put x is equals to 0 in equation 1, you will get y is equals to c1. So this is the point of intersection of equation 1 and y line, that is x is equals to 0 is nothing but the line equation of y-axis. Okay, similarly if you put x is equals to 0 in equation 2, you get the point of intersection as 0 comma c2. So we have these 2 points. We also know the area of triangle goes something like this, right? I'm not sure about the signs, so you can just look at the signs once, but it goes something like this. Okay, right? ऐसा कुछ होता है हमारा एरिया ऑफ ट्राइंगल का फॉर्मूला. सो हमारे पास Q है, हमारे पास P है, हमें R के कोऑर्डिनेट्स फाइंड आउट करने हैं. तो R के कोऑर्डिनेट्स क्या होंगे? इंटरसेक्शन ऑफ equation 1 and equation 2. So we can simply just subtract equation 1 from equation 2 and we will get the value of x. Then we can put this value of x in any one of the equations and we can find the value of y. So these are the intersection of two lines or the coordinates of R. Then we will have the coordinates of all 3 points P, Q and R, and then we can simply just put it in the area of triangle and leave it at that and simplify it to this point. Okay, moving on to example number 15. So we are given that a line is such that its segment between the lines is bisected by the point 1 comma 5. We have to obtain the equation of that line. So see carefully in the graph that is given to you. So this is the line segment that is already given to us. This the equation 5x minus y plus 4 and 3x plus 4y minus 4 is already given to us. We have to find the equation of the line such that its segment between the lines is bisected at the point. So what they are trying to say is, see, this is the, I'll just draw it again. So this is our line 1. Okay, this is 5x minus y plus 4 is equals to 0. And this is our line 2, which is 3x plus 4y minus 4 is equals to 0. We are told that the line segment that is between these lines is bisected at 1 comma 5. That is the distance of this and the distance of this is same. This is one thing that is given to us. We have to find the equation of this line. So how can we do that? Let's see how the approach has been taken in the book. So we are given these two equations. We have assumed that the point of intersection of the required line with 5x minus y plus 4 is, let's say, alpha 1 comma beta 1, and the point of intersection with the other line is alpha 2 comma beta 2. So because we have assumed this, we will know that the line 1 will satisfy alpha 1 comma beta 1 and the line 2 will satisfy alpha 2 comma beta 2. But यहाँ से भी हमारे पास 4 variables है. We will not be able to find alpha or beta ka value, right? So what we have done is we have just simplified both of these equations and found a relation between b1 and a1 and b2 and a2. Because we have found this relation, we are required to find the line between these 2 points, and the line between these 2 points, we know that the equation of the line will satisfy this point because it lies on that line. So this gives us that this is the midpoint. So we have another relation, alpha 1 plus alpha 2 upon 2 is 1 and beta 1 plus beta 2 upon 2 is 5. So what I'm trying to say is that since we know that 1 comma 5 bisects this line segment, we know that alpha 1 plus alpha 2 upon 2 will be equals to 1, and beta 1 plus beta 2 upon 2 will be equals to 5. So this is the other relation that we have. So from here, what we can do is we know that alpha 1 plus alpha 2 is equals to 2. Okay, so now we have substituted the value of 4 with the relation between these two. Okay, so what we have done is alpha 1 plus alpha 2 is equals to 2, and 20 alpha 1 minus 3 alpha 2 is equals to 20. So how did we get this? So the reason that we got this is we put the value of b1 in terms of b2 here, and then we eliminated b2 from both the equations, so that we had another relationship between alpha 1 and alpha 2. So solving these two, we reached the value of alpha 1 and alpha 2. Hence we got the value of beta 1 and beta 2 as well. And then we can easily find the equation by using any of the formulas that we have studied till now. Moving on to example number 16. So we have to show that the path of a moving point such that its distances from the two lines are equal is a straight line. Okay, so we are given these two lines. These two lines are not parallel because the coefficients are different. And let's say that h comma k is any point whose distances from line 1 and 2 are equal. That is given to us because moving points such that distance from these two lines are equal. So we have assumed that the moving point is h comma k. We have to show that the equation of the path that h comma k follows is a line. It is not any other shape. So h comma k is a point whose distance from 1 and 2 remains equal. So we also know that here we have used the distance of perpendicular formula, that is ax plus by plus c upon a square plus b square ka formula. So simplify, we know the equation distance is same. Because the distance is same, we have equated them and we have found a relation between h comma k. Now we already know that we have two relations. We get k is equals to 0, h is equals to 5 by 3. Thus the point satisfies the equations y is equals to 0 or x is equals to 5 by 3, which represents the straight line.